Okay, we'll go ahead and look at this next one. It's based on a 60-degree angle. So I'm going to start by sketching my angle over there. Oops, got too close to the edge of my screen, made everything go crazy there for a second. So that's a 60-degree angle, nice, simple. If I'm doing remember I need to look at my reference angle, so I drop down to my x-axis, and this point here is my point I'm looking at. And I'm talking about this triangle here with this value here for my theta. Now, once I have my triangle set up correctly, now I'm going to go ahead, since this is a 60-degree angle, this is one of those special 30, 60, 90 triangles. So remember, the short side is going to be 1. The hypotenuse is going to be twice as long as the short side, and I know the short side is always opposite the 30-degree angle. So since that's 60 at the base, that's 30 at the nose. So the short side is the side opposite the 30-degree angle, 1/2. The short side's half the side of the hypotenuse. That's just a special property of any 30, 60, 90 triangle. And then this is going to be a square root of 3. You could get that using the Pythagorean theorem, because 2 squared minus 1 squared would be 3. Take the square root is square root of 3. Now, once you get that, go ahead and think of this as opposite, adjacent, and hypotenuse if you want. Or you could use this point over here as having a value of +1, +3, and think of the x and y coordinates. Does not matter. So I'm going to have, in this case, my sine of theta, my sine of 60 degrees, would be equal to the opposite over the hypotenuse, so that's square root of 3/2. Cosine of theta would be adjacent over hypotenuse, 1/2. Tangent of theta is opposite over adjacent, so square root of 3/1. When you go to find your reciprocals, remember cos go with no cos. So sine didn't have a co, cosecant does. Flip that upside down, that is a 2/√3. Or you could rationalize that as 2√3/3. That's the preferred form there. Cosine goes with secant. Flip it upside down, you have 2/1. Or you could simplify it to just a 2. And then the cotangent goes with tangent. So cotangent would be 1/√3. Or you could rationalize to √3/3. By multiplying top and bottom by √3. So that gives you an idea of how to do these. I'll pause this and get you started on the next one as time allows. Okay, this next one, I don't like the fact that it's got a negative 150, so I'm going to start by getting a coterminal angle by adding 360, and that's going to give me a value of 210. That makes it easy to identify that I'm in this quadrant, quadrant 3, which is important to note. And my reference angle is actually 30 degrees. So this is another 30, 60, 90 triangle. So in this case, this is the short side opposite the 30-degree angle, 1. The hypotenuse is 2. This is square root of 3. That works for any 30, 60, 90 triangle. And you might want to go ahead and label these. I'll pick a different color so it stands out as opposite, adjacent, and hypotenuse. Or you could pick this point here and label it as a negative square root of 3 and a -1. And it's probably best to go ahead, since you're going in a negative direction, to call this side negative square root of 3 and call this side -1, because that'll help you as you get your signs right. But as we do this, our sine of theta would be opposite over hypotenuse. So in this case, -1/2. My cosine would be adjacent over hypotenuse, √3/2, or negative √3/2. And my tangent of theta would actually be my opposite over my adjacent. So it's -1 over negative √3, which means it rationalizes to √3/3. You notice tangent does end up being positive, which matches what we said in our notes, that the only thing that should be positive in quadrant 3 is tangent, and by extension cotangent. The others are negative. Tangent is positive because the two negatives cancel out to make a positive. I'll leave it to you to find the other 3 trig functions and try the other examples. If you need help, please let me know.